Hello, it's Keith here, and this is lesson 10 of the simple series of my 650 assembly programming tutorials. Now, we looked at how to do simple bitmaps, which was smiley on the BBC last time. This time, we're going to extend it and we're going to add joystick control, and we're going to move that little smiley around the screen. Now, the idea of this is that we've got graphics and now we've got movement, and this should be a template for you to start writing your own little game. Because if you've got a way of taking input and a way of drawing something on the screen, and you've got some understanding of how to keep an object moving and control its position, you could add enemies and make a game out of this. On the Z80 series, I actually extended this joystick tutorial into a game called YQuest, which I've been doing on my live streams, and I'll quite probably do something like that on the 6502 at some point as well. So anyway, let's go over to the code and let's see today's example in action. Okay, if I just go to the top here and we compile this. Okay, so here's our BBC emulator, and if I just make sure joystick is enabled, you can see I'm able to, I've got my little joypad here, I'm able to now move around the screen, and my little smiley will move around the visible area, and I've got some limits so that I can't go off the screen. I've actually limited the screen size to less than the total possible visible screen. I think I'm working at 320 by 200 pixels, even though the screen could be bigger, so that's why you never get to the bottom of the potential screen there. But anyway, that's the code example we're going to be looking at today. We're going to learn how to read the joystick and look at the conversion that's been done on this code since the simple bitmap series. Now, if you've not seen the simple bitmap series, this is just really going to cover the joystick part and also the control of the sprite part. We're not going to look at the setting up of the screen and things. We're going to skip over that. So you'll be able to watch this just fine, but once you have, please go back and look for that simple bitmap series example, because I can't cover all of it again. So okay, so first of all, we've got some definitions here. We're defining some 0-page entries here that we're going to use for the position of the sprite of the player. X and Y are the current sprite position. X2 and Y2 are the last sprite position, because we need to know where the player was, and we're going to use it in this case so that if the player tries and goes off the screen, we can bounce them back to the last valid position. So that's what we're doing there. We're defining those. These are for my general code here. Start of the program, turning the sound off. As I say, I've covered all of these before. This is relocating the code here so that we can use our graphics screen. And here we're just turning the screen on. Here we're just resetting the screen memory here, and this is the actual start of the program. Now, what we're doing here is we're defining an initial position for our player, because obviously we want the player to be somewhere sensible, otherwise there could be crazy values in the defaults. And then what we're doing next is we are setting a value in 0-page entry ZH of 0. Now, what this is by default our code is going to wait for us to press a joypad button, but we need to make sure it draws the first position of the smiley. So we're putting a dummy value in as our joystick reading. We're not really reading the joystick, and then we're starting the drawing routine just here. So that's just skipping over this. This is the code that's actually going to read in from the joystick and load the result of the joystick into ZH, 0-page entry. If there's no buttons being pressed, if ZH is 0, then it's just going to keep waiting until something is. Now here's our drawing routine. We're backing up the X and Y position into the second versions here, and then we're using a routine called blank player. Well, this is a modification of the smiley drawing routine from the simple bitmap example. We've still got our smiley just here, there it is. But then we've also got a new one, which is a blank bitmap of 16 0 bytes. So if we want to clear the smiley's position, we're just drawing that blank bitmap to the screen using this part. And if we want the smiley, we're using this version. So this is just two versions of the sprite drawing routine from that simple bitmap example. And as I say, this is all building up on that simple bitmap example. So that's clearing off the old position of the player there. Now the next question, of course, is how are we reading in from the joystick? Well, it's these read controls dual routine that's doing that, and that's where we're getting to the hardware requirements of the BBC. Now the BBC actually uses an analog joystick, so I'm not really doing it justice with this thing, but that's what we're working with today. So we're just dumbing it down to a digital joystick basically. These are multi-platform tutorials. We kind of work at the common ground area, so we're treating it as a 4-direction digital joystick. Now, the way we need to do things is we need to set the port up. This is the port that controls the joystick, and we need to set it to read, and we do that by writing a 0 to FE43. We then need to poll both of the axes separately. We need to process them in 2 runs. So the way we do this is we need to store different values to FEC0 here. And for the left and right, we need to store 0, and for up and down, we need to store a 1. Now, actually, A was already 0 as a result of this, so rather than wasting any extra commands, you can see I've remmed this out, but effectively A was already 0 here. And so we run this routine here twice, once for the up left-right part and once for the up-down part. And you can see what they're doing is they are basically setting that port for the data we want, and then they're waiting for the top bit to become a 0, and until they do, they just loop around here. When the top bit becomes 0, the data is ready. We read in from FEC1, and then we have to define a hit zone because it's an analog stick. It's never going to be exactly in the 0 area. So we're defining a dead zone that only allows a value less than 32 on either side to be considered a press in that direction. And then what we're doing here is we've got a command here that will set the first bit to 0 and the second bit to 1. And otherwise, we've got a command here that will set the first bit to 1 and the second bit to 0 here. And finally, if no buttons are pressed, we're setting both bits to 0 here. Now, I've marked these as right and down and left and up because this whole thing is run twice, and each time it's shifting bits into ZH. Now, the long and the short of this is that once this routine has run, you'll get these left, right, up and down in the bottom 4 bits of the 0 page entry ZH here. So this is based on the platform specific example, which we also had in Fire. If you want more, if directions aren't enough for you, please see that example. But basically, we're using that here, and that's returning the value that we need here so that we are able to carry on with our code. Now, in our code here, what we're doing is we're testing each of the bits with this AND command, and if the bit is 0, then the direction isn't being pressed, and so we're skipping over a set of commands that we would process only if the up button was pressed, only if the down button was pressed, and so on. And basically what we're doing is we're altering the X and Y values, which are our X and Y axis of our player, and we're moving in either individual units for the X-axis because of the way the bytes work for the screen memory, or we're working in 8 lines for the Y-axis here. So these are moving the player accordingly, depending on each direction that the player could be moving on the joystick. And then all we need to do next is we need to store those new values, and then we need to check the player's not gone off the screen. Now, top left of our screen is 0, 0. So if they go below 0, the byte will wrap round to -1, which is effectively 255. So we don't need to check a value below 0. We just need to check a value basically above 80 or above 200. Now we've got a slight subtraction here just to cope with the width and height of the sprite. But basically, if the player has gone over the x-axis position of 80 or the y-axis position of 200, they've obviously wrapped around somewhere. And so we're jumping to this player reset, and that's where we're using the backed up values that we stored just here. So we're using those to reset the player's position and keep the player on the screen. So whatever happened though, at this point we can now draw the new position of the player with this draw player routine. We then need a little bit of a delay. We've just got a very crude delay here, and then we jump all the way back to the top and we just repeat the entire procedure again, just drawing for the next position. And that's really all there is to it. So there we go. As I say, we've kind of extended our original example. We've taken that smiley face and we've made it move around, and we've shown some simple code, relatively simple anyway, that allows for the handling of a positioned object and making sure that it doesn't go over any boundary limits. And that should be enough to get you started on a game. And as I say, it was enough for me to start working on the Y-Quest, which was literally an extension of the Z80 version of this example. Anyway, I hope you found this interesting. If you have, please like and subscribe, go to the website, download the source code and give it a go yourself. But whatever you do, I hope you enjoy programming the BBC and programming assembly in general. Thanks for watching today, and goodbye.